Hello everyone, welcome to the GeoEcolologist. I am Dr. Krishnanand and you have been watching my videos on climatology, and in the previous sessions we have discussed about solar insolation and the heat balance or the heat budget. Today we are going to learn about this balance of heat on the surface of the earth across the latitudes, that is called latitudinal heat balance. So let's learn the details of this balance of heat which is maintained and what are the factors involved in it, nuances associated with it. But before we go ahead, do like and subscribe to our channel, and don't forget, as I say, to share the videos with others as well. So now, when we have learned already this heat balance or heat budget in the previous session, one more thing that is related to it is this latitudinal heat balance. When we say balance of heat across latitudes on earth, right? Because remember, in insolation lecture we learned that not all the latitudes receive similar amount of insolation. There is this decreasing trend from equator to the poles. So we must understand how this entire heat is balanced across this latitude on the earth, because remember, there has to be a balance sheet as well. So in heat budget, what did we do? We took this entire budget sheet of this incoming insolation, that is in the short wave radiation, and the outgoing, that is in the long wave radiation. So we tried and fix this balance between that. But here we are trying to fix this balance between different latitudes, right? From equator to the poles. How is this balance on the surface of the earth, not with the outer space incoming outgoing, rather than on the earth's surface across latitudes itself, right? So the amount of insolation received varies from latitude to latitude. That is the first important thing that we need to keep in mind when we are understanding about latitudinal heat balance, right? So what happens? The regions with equator and 40-degree north and south receive this most amount of insolation. So maximum insolation is received where? In the tropics, as we have learned in the previous sessions, right? So what happens? Where is the maximum gain of energy? This is the region, the tropical region, largely up to maximum of 40 degrees north and south. This is where the net gain is there, right? This is called the energy surplus region of the earth. Why is it called so? Because here the maximum solar insolation is actually received, right? So equator to the tropics, tropical areas, Tropic of Cancer and Capricorn, and adjoining areas, that is what the surplus regions are there. Now, when you know this balance act, what happens? If there is surplus, there has to be somewhere where there is a deficit, and there has to be a balance between the surplus and deficit. So from surplus, things will go to the deficit, and then there will be this equilibrium created, right? So that is where this balance of this equilibrium on earth, that is heat equilibrium or heat balance on earth, is created. So what happens? It means that energy from this surplus must go to this deficit area where there is a loss, right? That is the mechanism of this entire balance. So what happens? Regions beyond this 40-degree north and south latitudes, what happens there? There is a energy deficit. They don't receive as much insolation, and there is lots of loss here in outgoing radiation, right? So what happens? Remember, the factor is balance we have to find. And why is this happening? Remember the earlier lectures, there is this angle of incidence, this slanting sunlight. So the energy is constant, but area is increasing when there is a slanting light received. So that is the major reason, because of this insolation factor, which is surplus in one region and it is deficit in another region. There has to be a dynamic equilibrium established. That is where the normal steady state system, what we say, right? So we don't do that. Earth itself does it, right? Through its own mechanism. So let's understand the mechanism of the nature, how it creates this latitudinal heat balance on the earth and makes the possibility of life. So the first thing is to remember that this important logic that tropics received maximum heat, it should have been the hottest place on earth, is it? So remember what happens. Why is it not the most hottest place on the earth? This equator should have been the hottest place, but it is not so. Because of this balance, remember, there is a poleward shift in this energy if you see in this diagram. So the planet would have been inhospitable except for fewer regions near mid-latitudes. Now if this would have been the case, if this dynamic equilibrium would not have been maintained, the pockets of possibility of life would have been there on the earth only in certain places. But remember, our earth is hospitable in almost most of the places. Why is it so? Because of this balance. Why? Because this energy surplus region actually gives energy to this deficit region, and then there is this balance created, which we are studying as latitudinal heat balance. So this poleward shift of the energy. Now this is where the progressiveness is important of the energy. So let's learn furthermore. So how do we attain or how do we achieve this balance? Now let's understand that this is the surplus area, the tropical area, and this is the deficit area that we already know. So it means there has to be flow of energy from surplus to the deficit. That is the only possible outcome of this particular diagram that we are seeing. So how does this flow happen? It means it needs medium. It means that there has to be a messenger right from the surplus to the deficit who is going to carry this energy. So that is where planetary wind system, the atmosphere plays a pivotal role, and the oceans play a pivotal role. So remember, our atmosphere and the hydrosphere, the oceans, the ocean currents, these are the two major carriers of this surplus heat from the surplus region to the deficit region. And that is the entire mechanism, right? So the transfer of this excess heat from the tropics, and tropics are what? The surplus energy region, towards where? It goes towards this pole, and that is what is important, that there is this direction of flow important here. So towards the pole when it moves, what happens? This deficit is overcome, and then there is a steady state, an equilibrium created, or kind of a coexistence created. So there is not much of a problem in terms of habitability for human beings, only because of this natural mechanism, this dynamic equilibrium system, where atmosphere, hydrosphere, these are important factors or elements or carriers or messengers of these energies, which leads to this distribution of insolation that is coming from the sun. So that is where it is important. So let's analyze through another diagram. Most of the heat transfer takes place across the mid latitudes, that is where 30 to 50 degree. Now this is one important thing. When we are going to learn further the meridional circulation or the tricellular circulation, where this mid latitude cell, Hadley cell, okay, and then polar cell, these are important cells which are there in the atmosphere. In the lectures to come we are going to learn about it. So what happens, you understand, this is the equatorial and tropical zone. It means this is the zone of surplus, as we know, and this is the zone of deficit, as we know. Now this zone, this is the area. Remember this mid-latitude area, this particular area in north and south. This is also called zone of mixing. Why? Because heat is transferred from the high to the low. Here you have high, that is surplus, and you have low heat, low energy here. So what happens from surplus to deficit? There is a flow, right? So what is there? A flow is there from the tropics to the polar areas, and through this mid latitude it is there. So what happens? The most of this energy transfer is actually there in this particular 30 to 50 degree zone in the mid latitude cell. Hence what happens? This zone is the most turbulent zone in terms of atmosphere. The stormy weather condition is associated with this region, and that is where it is important. In details we'll be learning about this when we learn about the circulation of the atmosphere and ocean currents in mid latitudes later on in lectures to come. So now finally, let's analyze this entire balance through this diagram. I would suggest you to please pause the video and make this most important diagram if you are writing an answer for that matter related to latitudinal heat balance. Now here what you see, this poleward shift of the surplus energy, that is very simple. So this you can draw, and this is a parallel diagram where you have incoming energy and outgoing energy balance, right? So incoming and outgoing, this is where this balance is there. And how this balance is created? Remember, through the transfer of energy. And through whom? Who is the messenger here? The atmosphere and the hydrosphere, the oceans are the messenger, which take this energy which is coming here in this zone, the surplus zone, the plus zone. So if you want to draw a diagram, you can also say this is a plus zone, right? So this is the plus zone on both sides of equator, and this is the minus zone on both sides of tropical zone, right? So what happens? From plus to minus there is a flow, right? So plus to minus there is a flow and incoming is here, right? Maximum insolation received is here. So this is how this entire mechanism works. So these warm ocean currents go to the polar areas and then cold ocean currents again come back. Then this is a oceanic system circulation happening. And similarly what happens, the wind system, the planetary wind systems that we are going to learn in the lectures to come, that also accordingly varies over the tropics and over the poles. So that is where we understand those important wind factors that are responsible for carrying this energy towards the pole. So that is where it is important to learn the transfer of this surplus energy from lower latitudes to the deficit energy zone of the higher latitudes. And this is where this entire balance is maintained. So maintenance of overall temperature balance over the Earth's surface is only due to this latitudinal heat balance factor. So remember this latitudinal heat balance factor as the most important process in terms of distribution, the spatial distribution. Remember in geography, spatial distribution of phenomena we study. So in climatology, we study the spatial distribution of what we receive from the outer space, that is this incoming solar radiation or insolation that we say. So when insolation is received, we now distribute it. So what happens? Analogy again. So what is this? When you receive income, what happens? You actually distribute it, right? To create a balance in your family. So you allocate some money for food, you allocate some money for shopping, you allocate some money for the educational purpose, for health purpose. That is how you distribute it. Otherwise, there will be an imbalance created. So you have to have a balanced life. That's why those income has to be distributed in the balanced way. This is very similar to the nature that we have adopted, right? Nature has this interesting idea of balancing this entire insolation, and that is what we have studied, this entire surplus and deficit balance across the latitudes. That is where this latitudinal heat balance is important to understand. So now, when we know this entire mechanism of this balance of heat across latitudes from lower to the higher, from equator to the poles, in the sessions to come, we are going to learn further about the horizontal and vertical distributions of temperature on Earth. So stay tuned, stay safe, and all the best wishes.